All right, Mrs. Navard's statistics class had just completed the first 3 steps of the Where Do I Stand activity on page 90. The figure shows a dot plot of the distribution of height for the class along with summary statistics from computer output. Okay, so you don't need to know any prior information. This is all you need to know, okay? Just this dot plot here. So Lynette, a student in the class, is 62 inches tall. Find and interpret her z-score. Okay, so if we remember correctly, we know that our equation for a z-score is z, right, is equal to the value minus the mean, all divided by the standard deviation. Okay, I'm abbreviating dev, right, for deviation. Okay, so we are given the value, okay, so that's 62 inches tall. Our mean, if we take a look at the table, is 67. Our standard deviation is 4.29. We set that equal to the z-score, and then we plug that into our calculator, and we solve. So 62 minus 67 is -5. Divide that by 4.29. That ends up being a z-score of -1.165, but we're going to say -1.17. Okay, so what does the z-score mean? Well, this means that Lynette, how do you spell it? So Lynette's height of 62 inches is 1.17 standard deviations below the mean, or you could say average, height of the class. Okay, so Lynette's height of 62 inches is 1.17 standard deviations below the mean, or average, height of the class. Okay, so that's what the z-score, or that's how the z-score can be interpreted in this case. Okay, number 2, Brent is a member of the school's basketball team. Okay, where are we? And is 74 inches tall. Okay, the mean height of the players on the team is 76 inches. Brent's height translates to a standard deviation score of -0.85 in the team's distribution of height. What is the standard deviation of the team member's height? So we need to find, if we go back and look at our equation, we have z is equal to the value minus the mean over the standard deviation. I'm just going to abbreviate it as STD. And we need to figure out the STD. So if we just use some basic arithmetic, we could solve for STD. So we could do, okay, well, STD times z-score is equal to value minus the mean. We want to get standard deviation by itself, so we're going to divide by the z-score. So it ends up being our standard deviation is equal to the value minus the mean divided by the z-score. And lucky for us, we have that data right here. So let's read that again. Brent is a member of the school's basketball team and is 74 inches tall. So his value is 74 inches, but right now we're just gonna go with the math, okay? So the mean height of the players on the team is 76 inches. Okay, and Brent's height translates to a standardized score, that's the key, standardized score of -0.85. So our z-score is -0.85. So all we have to do is plug in those values right here. So we have to do the value, 74, minus 76, divided by -0.85, and set that in your calculator, and what you get, let's take a look for 1 second. So let's take our calculator. So what is it? 74 minus 76, divide that by -0.85, and that gives us 2.35. We're going to round it as, okay? So what does this mean? This means that the standard deviation, we could say the standard deviation of the, what is it, the school's basketball team, the standard deviation of the school's basketball teams, what is that even, the school basketball teams, I don't even know, teams, does that even make sense grammatically? Teams' heights, the standard deviation of the school's basketball team's height is 2.35 inches. We want to put that in context. Or you could say that the heights of the school's basketball team players, or you could say the height of the players varies 2.35 inches from the mean. Okay, so that's another way to say it. It's talking about variability. So that's number 2. And that's check your understanding for Z-scores.